In today's lesson, I'm going to be teaching you about congruence. So congruent figures are the exact same size and shape. Okay, so two figures need to be every single time the exact same size and shape. Now, when you test for congruence in triangles, there are 4 different conditions. Okay, as long as one of them fits the triangles that you're testing, then you can say that that pair of triangles is congruent. Okay, so the 4 conditions, and two triangles don't fit every single one of them. You just find one of them that the pairs of triangles can fit. So there are 4 different conditions. I've just written in basic form what they mean in words, but if you look at the table that's online, you'll be able to find images as well showing what these actually mean and a more in-depth mathematical way of writing their conditions. I've just done it in really simple terms. So if you want it in simple terms, you can pause here and then write this in your books. So the first one is SSS, which stands for side, side, side. So if you have 2 triangles, all 3 sides in both of them must be exactly the same. That's the first one. The second one, SAS, side, angle, side. Okay. One of the angles between both triangles must be the same. And then the 2 corresponding sides next to it must be the same as well for both triangles. The third one, AAS, angle, angle, side. 2 angles are the same and 1 side is the same between 2 triangles. And then we have RHS, which basically means you're looking for a right-angled triangle. So right angle with a little square in the corner. You need to make sure that between 2 right-angled triangles, the hypotenuse, which is the slant side, and the longest side in the triangle, and one other side in the triangle are the same between both triangles. So if you have 2 right-angled triangles, both the hypotenuses are the same length, and then one other side as well is the same between the both. Okay, so I've got 4 examples to practice with. The first, are the triangles congruent? Explain your reasoning. Well, in order for us to know whether they're congruent, we need to match up the sides with each other between both triangles. So what we can do is we can underline the sides that match, or we could redraw one of them to have them facing the same way next to each other. Now, what I'm going to do is I'm going to circle the fact that the point in this triangle is 111 degrees, and the point in this triangle here is also 111 degrees. So you know that these 2 green points must match up with one another. Okay, so what I'm going to do is I'm going to redraw this to make it the same way as this. Okay, like so. Now you need to imagine that you're taking this and flipping it to be the other way around. So you want this triangle here to end up looking like that. This is how it's going to be redrawn over here to match this triangle that's already facing that way. So basically we're redrawing this like this. Okay, so the 24 degrees ends up being here. The 12 centimeters ends up being there. The 7 centimeters ends up being there. The 16 down here, and then the 111 up the top. Okay, so basically what I've done is I have taken this triangle and turned it around to make it face the same way as this, because now it's easier for me to see if they're the same triangle. Okay, and I use the 111 as my starting point. Okay, this angle here matches up with this one, and then this angle here matches up with this one. So you can turn it to match each other. Now, let's see what we have. We have two angles that are the same between both triangles. So two angles, this one, that one, that one. And then also one side length. So if we take our sheet, we've got two angles. So we need to find, two angles and one side. Well, these two triangles, angles the same, sides the same, sides the same. So these two triangles are congruent because they fit the condition AAS. Okay, so I'd write yes. Now, you could be a little bit more explicit in your answers, but I'm just telling you why and the condition. Okay, it's simple answer. Okay, we're not allowed to use the 16. We're not allowed to use the 7 because there are no values that are given to us in the other triangle. So we can't just assume that it's 16 centimeters here, and we can't just assume that it's 7 centimeters there. Okay, we're not allowed to do that. Actually, I forgot the 45 degrees here. Also with this angle, we're not allowed to assume that that's 45 degrees. If they're not given to us, then you can't assume. It's only what you're given. Okay, next one. We have two right-angled triangles. So straight away you're looking for RHS. We need to see whether between these two triangles, their hypotenuses are the same and one other side. So let's see. You should know from your knowledge of when we were doing trig that the hypotenuse is the longest side of the triangle that is opposite the box in the corner, as I like to say. So these are our hypotenuses. If you don't like looking at the triangles like that, you can always flip your page to make them face this way if it's easier for you to recognize it's a right angle triangle. So I might just leave it like that actually. Our hypotenuses are the same. Good, that's a good start. Now we need to see if one other side between the triangles is also the same. Well, look over here. We've got 48 centimeters on this side here and 48 centimeters on that side there. So yes, there is another side that's the same. Since the hypotenuses are the same and one other side length, I can go ahead and say that yes, these triangles are congruent because they satisfy this condition. Again, you can be a little bit more in detail with your answer, but I'm just, in simple terms, writing yes because of this. Okay, so yes because it fits this condition. Okay, let's get rid of that. Question number 3. Are the triangles congruent? Explain your reasoning. All right, so let's get these facing the same way and we can go from there. What I think I'm going to do is I'm going to turn this triangle here to face that way because for me personally, I like the way this triangle is sitting. It's easy to read for me, whereas this is more like an upside down slanted triangle. So I'm going to literally pick this triangle up and flip it over to suit the orientation of this triangle here. Okay, now what I can do is get my green and think, right, well, I'm looking at these two triangles and I'm imagining what this would look like if I flip it upside down. And I know that this is the point of the triangle, the angle in this one. And in this triangle, the pointed angle is 130 degrees. So I'm using that as my starting point. Okay, so I need to flip this so that this ends up being here. Now, if I turned this like the triangle like that, this 6 would end up being here. So I can write 6 there. The 10 is still the longest side down the bottom. And then I've got my 28 degrees in the corner. Okay, so now I've literally taken this triangle and flipped like that. Okay, so now they're facing the same way. Everything that I've got in this one is written in there. I'm going to go ahead with my coloured pen and colour this in purple because it corresponds with this side. This 6 is blue, so that 6 on this side must be blue as well. And then we will use black, I think, to circle these angles. So remember, you're not allowed to use sides that don't have anything on it. So we're not allowed to use this angle here. We're not allowed to use that angle there. And we are not allowed to use this side length here. So all we've got to work with is basically these parts of the triangle. Okay. Now, the side length down the bottom is the exact same. So tick. The side length over here are the exact same, so tick. But let's look at our angle. This angle in here is 22 degrees, but this one is 28 degrees. Now, because we have two sides and an angle, we are trying to fit two sides and an angle. So the SAS condition, one angle's the same and two sides are the same between two triangles. We're trying to fit this condition here. But the problem is, we do have two sides the same, but the angle that we want to be the same is not. This is 22 and this is 28. So no, these triangles are not congruent because they don't fit the SAS condition. Again, my answer is very simple. You can go in more detail. No, because they don't fit SAS, because these angles are different. And then a lucky last. Are these triangles congruent? Explain your reasoning. Well, I've got 3 angles given to me here. I've got no angles given to me here. So in that case, I'm not allowed to use any of these conditions that have angles in it. These are not right-angled triangles, so I'm not allowed to use RHS. Cross that one off. This condition has 2 angles in it, but this triangle doesn't have any angles in it at all, so I'm not even allowed to use any of the conditions that have angles in it because you can't just assume. So that's gone. This one has an angle in it, so that's gone. So basically all that leaves me is SSS, side, side, side. So for these 2 triangles to be congruent, I need to check that all 3 sides are the exact same lengths between both. So let's check to see if that's true. Right. Because we know that this is the same bottom length, I can go ahead and underline that in pink. Okay. Now you'll notice that this side here and that side there are the sides that have less of a slant compared to these insides here. Okay, I know that it might feel, I guess, normal, if you can say, to just get this triangle and put it on top and think, oh nah, you can do that. But in actual fact, look at the slant of this side and this side. This one has more of a slant, just like this side, and these sides are more straight. So in actual fact, the 21 here corresponds with that side there, and the 20 here corresponds with that side there. Okay, because you're literally taking this triangle here and you're going like that, so that that slant and that slant side match up with one another. Okay, so I'll actually redraw the triangles very inaccurately. Okay. Okay? So this triangle is that one, and this triangle is this triangle once it's flipped the way that we want it. And we can see that all the sides are exactly the same between both triangles. 11 is down the bottom, 11 is down the bottom here, 21 is this side length here, 21 is this side length here, 20 is this side length there, and 20 is this side length there. Okay, so even if these numbers were the same between both triangles, but they were in different places, that would not mean that they're congruent. They need to be the exact same numbers in the exact same places as one another. And because they are, so the 11s are down the bottom, 21s are this slant here, and the 20 is that slant there, we can say that yes, all the sides between the two triangles are the same. So these triangles are congruent because they fit the SSS condition.